Today we're going to talk about motives and side effects of microdosing with psychedelics among users. These are the authors of this paper. The paper is found in the International Journal of Neuropsychopharmacology. I'm Geoffrey King, first-year master's student in the Safety and Occupational Health program. And I want to just take this chance to thank all you who made this education at ROMCO possible. Those of you who are here and those of you who are listening online, thank you. I also want to thank you for making Journal Club obligatory. Really, there's been some great discussions in here. I want to thank all those that have presented ahead of me. You've really prompted some great discussions. So I just really want to thank you guys for blazing that trail for me. The purpose of this paper is really a lot like the purpose of any good research paper. It's an effort to bridge the knowledge gap. The paper talks about media portrayals and anecdotal input as reasons for their efforts. I think that a lot of folks have an idea about what microdosing looks like, or who the people are that are microdosing. I also personally have some anecdotes from my experience in the construction industry, in the mining industry, in the oil and gas industry. I've met a few people who tell me they're microdosing. Not only are they microdosing, they're microdosing at work. Not only are they microdosing at work, they're microdosing while operating machinery. And right? So I see some faces here. What does that look like? That's kind of what's prompted this discussion for me. The other thing that's prompted this discussion for me are the recent changes here in Utah. Less than a year ago, psilocybin and MDMA were legalized for mental health treatment at a couple of hospital networks here in Utah. The paper has these aims for their investigation. The history of, they want to investigate the history of psychedelic use among microdosers, the dose and schedule they use, the prevalence of microdosing in the work environment, their motivation to microdose, the respondents' motivation to microdose, and the potential negative effects. And you're going to see this slide again. We're going to try to decide if they were successful in their aims. What is microdosing? The practice of repeatedly using low doses of psychedelics. Includes lysergic acid diethylamide, or LSD, and psilocybin. And a microdose is not intended to cause hallucinations. Side note, the word microdose is a misnomer, as the typical suggestion for use is 1/10 or 10 to the -1 of a, quote, normal dose. And you'll see I put the word normal in quotes all through here because what does that mean? And after reading through the paper yet again, I realized that in fact they do have a definition for a normal dose based on a number of references, a number of cited sources. So we'll talk more about that. But it's certainly not 10 to the -6, as you would think from the word micro. Anyway, this is a cross-sectional study. The design is an online questionnaire found on psychedelic websites and fora. This online questionnaire covers demographic information, psychedelic substance use history, motivation to microdose, motivation to stop using psychedelics, and the negative effects of microdosing. Data were entered into the statistical program SPSS, version 24. Respondents who reported to have never microdosed were excluded from analyses. Respondent demographics were categorized into those who currently microdose and those who used to microdose. Frequencies were reported for age, gender, education, continent of origin, daily occupation, psychiatric, neurological, physical diagnoses, and psychedelic use history. In total, 3,590 of 5,681 respondents consented, were 18 years or older, and completed the questionnaire. 2,472 respondents were removed from further analyses because they did not have any experience with microdosing, resulting in a total sample of 1,116 respondents. Here's a table, a couple of things that I find interesting here. So just to give you a frame of reference, those that are currently microdosing are 887. Those who stopped microdosing are 229. And we're going to talk more about this later, but you can understand why the vast majority of these people are currently microdosing, because this questionnaire was put out to a psychedelic forum or psychedelic websites. So to me, that's just wanted to point that out. And then also, what's interesting here, if you look at the percentage of those that are currently microdosing that are educated in this way, and the percentage of those that stop microdosing are educated in this way or that have these characteristics, these percentages are roughly the same all the way down. So it seems to be the same type of people. I think this is the way I understand it, is the same type of people are currently microdosing as the same type of people that stopped microdosing. So that's one interesting thing. The other interesting thing about this table to me, the compelling, is that their level of education. The vast majority of these people are educated. This study was done in the Netherlands, so primary is elementary school, secondary is high school, tertiary is college educated. So the vast majority of the respondents are, in fact, college educated. Another table here. I'm going to barrage you with a few tables. Excuse me. This has information about regular dose details. And you can see we're not just talking about LSD. We're not just talking about psilocybin. There's a wide range of psychedelics here that we're talking about. This study seems to couch the microdosing information inside of a broader survey of all of these substances. So here they're really just talking about a regular dose. So these are examples of regular doses. And the interesting thing about this table, to me, the compelling, I'm trying not to say the word interesting all the time. The compelling thing about this table to me is that a lot of these people don't know their dose. This almost looks exactly the same, but this just talks about microdosing. So that's their definition of what a microdose is. And again, most of the people microdosing, or a large percentage of the people microdosing, don't know the dose. Yet another table here. This is the means of administration of these psychedelics. And I only bring up this slide just to talk about the one person that decided to say this for every single drug. Kind of questions the validity of the study to me, right? These are the kind of hurdles that you have with an online questionnaire, in a cross-sectional study. Some results. Remember this slide? We're talking about the aim of the investigation. We're going to kind of parse these out. History of psychedelic use among microdosers. All respondents used at least one regular dose in the past. And the majority of respondents who microdosed with LSD and psilocybin reported microdosing several times per week. The most reported regular and microdose for LSD was 200 micrograms and 10 micrograms, and for psilocybin, 3.5 grams and 0.5 grams, respectively. So again, not a micro dose. That is a misnomer. Up to 67% of respondents indicated not knowing the dosage they normally consume. 1/2 of the microdosers indicated to have microdosed while working. The majority of those are learning or studying or doing computer work. Operating machinery was not one of the options for occupation. Motivation to microdose. 37% of respondents said they do so for performance enhancement, focus, concentration. 29% said mood enhancement, 15% just tried it out of curiosity, and 14% use it for self-medication. 1/5 of all microdosers reported to have experienced some kind of psychological or physical negative effect. The most reported side effects while microdosing were psychological in nature and occurred acutely while under the influence. The main reason for users to have stopped microdosing was not due to negative side effects, but rather because they deemed it not to be effective. 1 to 3% of microdosers indicated that negative effects lasted more than a few days after dosing. This is important. Here's some weaknesses of the study. Obviously, self-selection bias is a problem here. An online questionnaire, you're going to have people that, we're not picking these people; they're picking themselves, and that offers up a whole number of problems. These respondents were surfing psychedelic websites and volunteered to perform the study. These people skew toward having a positive outlook on drug use. I think that's an assumption we can make, or psychedelic use. And now back to these negative effects, it is important to have some specific negative effects. There's a limited assessment here. What does that mean, negative effects? It's not enough to say that 1 to 3% had negative effects lasting longer than a few days. What is a negative effect? I mean, if a parent thinks that their child was, abducted and replaced with a robot, and so they're no longer taking care of their child, I think that's a problem. And I think, when we just talk about negative effects, we need to granularize that and really figure out what these negative effects are. Lack of dose standardization and unreliable dose reporting is another weakness for this study. How does dose correlate to these negative effects? If we don't have a better understanding of dose, it's far more difficult to track negative outcomes. Strengths of the study. I did weaknesses first. Strengths of the study: concise, easy to digest. I found it easy to read, frankly. The large sample size. Now, this was important to me. It was the largest sample size I could find on the topic. Real world, so not a lab. And when I say real world, right, it's an online questionnaire. But it certainly is not a lab, and I think that's an advantage. I think that's a strength. And again, 67% of respondents don't know the dose of what they're consuming, up to 67%. And so I think that's a knowledge gap that was identified. I think there's some other knowledge gaps that are identified. Some questions for group discussion. These are some that I have. I'm really interested to know, after you guys looked at those tables, if anything jumped out at you, anything was particularly compelling for you that you want to talk about. Let me ask this. Do you think the authors succeeded in terms of the aim of their investigation? I guess, really, I want to know what surprised you about this study. This one is important. I really want to hear some feedback from you guys. I value your insights. Why do you think performance enhancement was the most common reason for microdosing? And the big question, do you think this motive is ethical? Do you think it's an ethical motive to want to enhance your performance at work?
Did they look into kind of the responses for their reasoning versus what drug they were microdosing on? Because that was a really long list and they all have very different effects.
Right. Yeah.
What specifically those people?
Yeah. So the question is around performance enhancement and whether or not those folks and to kind of parse that out and see what drugs people were using, or what psychedelics people were using, and how that relates to their performance enhancement and their response for that question. And that was not done. And I think that's another weakness of the study. I really think some multivariate regression could have been put in there to really bring that out.
I think this ethical question is really interesting. I think it may have a broader applicability to medications that are prescribed for attention deficit hyperactivity disorders. I remember I had a psychopharmacology class in grad school, and the expert teaching the class mentioned Ritalin and other drugs prescribed for ADHD are not disorder specific. They'll benefit any person who takes it in terms of being able to pay attention for longer. And we know that these meds are popular on college campuses and in some workplaces with, probably in the tech sector, where they have these time crunches to hit major deadlines and so on. The ethical question is really interesting, and I do think there's a widespread use of certain meds already for performance enhancement. I I was surprised that that was an argument for psychedelics. I thought it would be mental health myself.
Yeah, only 14%.
Yeah.
That was a surprise, wasn't it? Yeah.
Mhm.
Please.
I've read that like people on the internet recommend microdosing as a replacement for ADHD meds and also antidepressants. When I look at this like list of options on figure 1, I feel like they could all, like if you were taking them to replace your antidepressants or ADHD meds, like you could probably say yes to all of these. And so I don't know if it's really like that specific.
You think all of those could be used to replace?
I mean, these just could all be motivation. Like, and also the performance enhancement has like 4 categories under it.
Thank you. Any other surprises? Any point in this conversation you were like, oh, that's a surprise?
The precision of measurement for occupation was pretty high level and not using a standardized coding system. So it would have been helpful to know more about the types of workers.
Right. And so they didn't really answer my question. My question was, how many people are microdosing? And that's a really difficult question to answer, right? Because, you know, it's legal in Utah for study by hospitals, you know, and so it's these kind of questions when we're talking about illicit, you know, frankly, illicit drugs. That's you know, if you want to find out and you want to do studies on this, how do you go about that? You know, obviously this is, you know, cross-sectional study. We need, I think a placebo-controlled study would be great. I really just chose this because of these large amount of respondents. I think that to me was compelling.
I've got a question online from Andrew.
Yeah.
He said, I may have missed it, but did anyone report negative effects on their work productivity, perhaps in a way that could be described as under the influence or comparable to other drug or alcohol use?
That wasn't one of the negative effects that they talked about, and that really, Andrew, speaks to the weakness. One of the weaknesses of this study is that we really, you know, it's one thing to just say negative effects, right? What does that even mean, right? Is it negative effects at work? Is it negative effects? I really am interested to know that more. So yeah, thanks for the question, Andrew. It wasn't covered at all. It was pretty broad, negative effects. If microdosing becomes more mainstream, what are the potential risks and societal impacts? I think, sorry, I don't know your name, our friend in the front row here. Excuse me.
Dr. Olson.
Dr. Olson, thank you.
Yeah.
Dr. Olson already pointed out that we already have lots of societal impacts from drug use, particularly over the counter. And so does this change that as microdosing becomes more mainstream? Does it make it, is it safer? I mean, there's a lot of questions, more questions than anything come out of this. And I think that's maybe another strength of these type of studies is they open up many more questions. So they bridge the gap in some ways, they bridge the knowledge gap in some ways, but in other ways, these type of studies really come up with more questions. And I think that's a strength, and it opens the door to future studies. Yeah.
I think one kind of interesting thing when you're looking at microdosing or studies that want to look at very specific style of drug use. I'm from the SF Bay area. I worked in tech. I know a lot of people who microdose, and there's kind of like a barrier of entry. Like you're not just looking at people who are using illicit drugs, but you're looking at kind of like, for lack of a better term, like the top 1% of those people, right? Typically these people have like, they have money to burn. They have a desire to kind of like track what's going on when they use these different kinds of substances. And so I think in terms of societal impact, it's very interesting because you're already looking at people that are kind of not in the mainstream anyway, and they're probably more responsible users of these kinds of substances. But I think one societal impact that's not talked about a lot is that, illicit drugs, especially those that, are purchased here in the States, they have big societal impacts for the people who are making them or bringing them across the border. And as that market grows, right, we see a lot more kind of just general violence and kind of like child labor and things associated with illicit drug use.
Uh-huh. So similar could expand what we're already seeing with illicit drugs. And you make an interesting point also about the potentially responsible drug users. Yeah, they're educated. I mean, the vast majority of these people have an education, and it is particularly popular in the tech industry. So thank you for highlighting that. Yeah.
A lot of interesting stuff is I've consumed. I haven't really researched out about microdosing that I've found is like in terms of like treatments for like Alzheimer's and dementia, kind of like an older patient population. And just like I said, I'm not going to speak to it because I don't know much about it, but all those studies have always been really interesting and how these kind of hallucinogenic drugs and substances can kind of help people in that regard as maybe an alternative to other medications. Even with pain, I've seen stuff with it. That's just where I've heard microdosing pop up is kind of as one of those like alternative routes. So I think that's kind of interesting. Just the idea that in like the small quantity, it could be a positive, but
I completely agree. And even a regular dose could be a positive for those folks who have, there's so many people. We all know somebody who's in and out of. There's this cycle of homelessness and mental illness and drug abuse, frankly, and these are known as not being as addictive, which I think is another compelling reason to learn about them. And again, more research that's kind of the general. I understand it's less addictive, but I think you raise a huge point. There's so many people that are in and out of homelessness, in and out of mental illness, in and out of getting arrested, in and out of jail that haven't tried it, and I think we should try it a little earlier in that cycle maybe, and it could help some people. And that speaks to mental illness, but I hadn't really heard a lot about Alzheimer's and cognitive decline and how that can help them too. So that's, yeah, so much to talk about.
So there's a scientific need with medications that have been illegal for a long period of time or are only partially legal in some states and not federally, because we're just missing science on their effective dose for particular therapeutic purposes, their toxic or lethal dose, side effects. So a legal prescribed medication will have a whole profile that pharmacists and scientists have worked out, and we don't know a lot. And so like marijuana, for example, is widely used by people as a sleep aid, but scientific sleep research with components of cannabis is quite limited because you can't legally do research and grant-funded research on cannabis as a sleep aid isn't available. So there's a big scientific need in these medications that may be becoming legal or fully legal or legal for therapeutic purposes. And people are definitely curious and they're trying it out.
Right.
And but I think it's a scientific need, and it's been limited in part by federal. You can only do research is difficult to do with drugs that are illicit.
Yes.
Yeah.
That you open up a whole Pandora's box of conspiracy theories there, right? And for me, but without getting too far into that, you raise a great point, and I think that's yet another reason why these studies are important. We oftentimes will categorize people and just kind of shake our head at somebody who's trying this, and perhaps they are, perhaps they're at the cutting edge of a really great point of research, perhaps, and again, more information needs to be, more actual research needs to be done. Yeah. So any more of my friends have any comments or questions?
Going once, going twice. All right, great job.
Look at this. Oh, I get you.
Oh, my plants are gonna change again.
I think you should do this. Triangles are with the superior shape.
Perfect. Can you guys hear me?
Yes.
Sweet. All right. So, my name is Porter Roskelley. I am also a first year master's student here, and I am studying industrial hygiene. It's been great. Been loving meeting everyone. I wanted to give a little background on this article. So it's called "The Mosaic Oat Genome Gives Insights into Uniquely Healthy Cereal Crops." Sure, everyone woke up this morning and the first thing they wanted to hear about was oats. It's usually pretty interesting for people. No, I'm just kidding, but I'm going to do my very best to make this simple and understandable because for me, even it was at times a little bit difficult to understand. A little backstory. My father-in-law is one of the scientists who helped with this study, and so I wanted to, I guess, get some extra brownie points, understand a little bit more about what he does. And so one more caveat, the article that you guys all have, that's the 2022 version. There is a version coming out in Nature magazine in 2025, which is an update to this article. It's not published yet, so I couldn't send it to Bubba to actually have printed out here. But it's just an expansion, a lot of what I'm going to be talking about today is an expansion of the article that you guys have. So jumping into it, give you guys a little bit of background on oats. So people know Honey Nut Cheerios, they've got oats in them. And the reason why oats are great is, and have been growing in popularity over the last little bit, is because they're super rich in fiber. So that beta glucan aspect is actually why Cheerios can put the heart on their box, talking about lowering cholesterol. I just think that's kind of interesting. Oats are also a great source of protein. So a lot of people these days are choosing to have like a plant-based diet. And sometimes they have a hard time finding alternatives to animal protein, and oats are actually really high in protein, and a lot of people are starting to incorporate them more into their diet just based off of that. And on top of that, they have a lot of good vitamins and minerals, things like iron, magnesium, and zinc. So they're really like a powerhouse crop, and are gaining a lot of traction and popularity, which is kind of a funny thing to say because everyone knows what oats are, but they're starting to be used more and more. Jumping into the weeds a little bit, we'll talk a little bit about the oat genome itself. So all of us human beings, we are what is called a diploid, which means we have two chromosomes. So females are XX and males are XY. With oats, it gets a little bit trickier. So anything over two chromosomes is called a polyploid, and oats are a hexaploid. And so my best effort to keep this simple. So let's just call C right here like an ancestral version of an oat, a wild oat. As it goes down breeding, this example, it breeds with D, so we end up with CCDD. And then as you breed with more variations of oats, we get this hexaploid structure, which is AACCDD. And that leads to a lot of complexities in oat genetics themselves. So to kind of give you guys an example of what I'm talking about, here is a wheat map of the genome. You can see how there's not a ton of noise here in the middle. There's not a lot of crossovers and interruptions between the chromosomes. They're all just kind of connecting to their respective areas. But with oats, you can see it gets a little bit messier in here. Is that making sense to people? Perfect. So I know it's a little bit out there, but obviously you can see that this is a little bit tighter than all of this. And so that is specifically due to unique evolutionary changes in the oats as, history progressed. And so there was lots of swaps and flips and weird duplications of certain chromosomes that this study was aiming to understand. And let's see. There we go. So segueing into am I supposed to be pointing this at something? Sorry, the figure. Oh, there we go. Okay, perfect. So the goal of this study, what they were really wanting to do is help breeders create better oat varieties. And what I mean by that is if we can look at some of the characteristics of these super interesting oats, we can see the top left right here, those would be considered a dwarf type of oat, obviously because they're a little bit shorter. We can see that other varieties of oats have different characteristics. Like this one looks like it has a little bit more flowering than, say, this one. Some of them are taller than others. And obviously in basic genetics and science, the chromosomes behind everything are the reason why certain genes are being expressed the way that they are. And so continuing on, the scientists, aside from wanting to just help breeders create better oat varieties, like things, standing up taller, having more bundles, which I learned is actually really a super admirable thing for oats to have, because as farmers are, using their big machines to collect the oats, if an oat or a stalk is laying down flat, then the machines won't have as good of a time picking them up. So I was actually learning a lot about like what makes an oat sexy, I guess, if you will. And they also were wanting to identify, what genetic variations impact breeding, and then find methods that would help them to be able to make other types of plants more sexy, for lack of better terms, if you will. So all right, perfect. Wait, I think I skipped a slide. Let me go back. Okay, no, we're good. So jumping into the methods they use, this is where it gets really complicated. And so we really don't need to jump into that too much. I'll just tell you guys the name of the gene sequencing that they use. It's called PacBio Hi-Fi plus Hi-C sequencing. The way that all works is like really complicated. There's like really long YouTube videos about it if you guys really want to learn more about it. But that's the process right there. We're not going to jump into the weeds too much on that. But after they got the sequencing maps all done, they put all of the oat varieties into groups to better be able to compare them to one another. And what I mean by that is they wanted to see commonalities between different types of oats. So they grouped them into core, shell, and cloud genes. And jumping into really quickly what each of those mean. Core genes are the basic growth and metabolism genes. They just are in charge of, making sure that they actually grow and work. The shell genes are responsible for disease resistance. So there's a whole bunch of diseases that always affect oats in a bunch of different ways, depending on what area of the world that they are in. And the cloud genes, those are to do with, sorry, I apologize, surviving like extreme weather. So depending on the regions, hold on, I think I might have double clicked. We didn't go over this, correct? Okay, I apologize. I double clicked and I was like, wait, we're missing something. Really quick, I apologize to do that. He is jumping back super quick. So the study itself, what it was, the scientists in this study, there's 22 of them, and they gathered 23 different varieties of oats throughout the different areas of the world. So there's some in, North America, Africa, Europe, and then there was one from South America in Uruguay and one over in Australia, if you can see in the bottom corner. And they created what's called a pangenome for the oat family. And a pangenome is a collection of genes for a specific species. And the reason why you want a pangenome is because it gives you kind of the genetic map for a type of crop that helps you to know what trait is linked to what chromosome, if that makes sense. And so in an effort to get as much biodiversity, I apologize, as possible, they tried to grab some of the wild and like ancient versions of oats, as well as some weedy, and cultivated like, more generic oats that we see being used in today. And so then we jumped into the goal of the study. Obviously, they're wanting to understand how different oat varieties relate to each other, and you can't do that without the pangenome. We jumped into the methods, and again, I apologize that we got a little mixed up, but we were talking about the core, shell, and cloud genes. And the reason why they grouped all those together was to be able to understand what chromosome is in charge of the gene expression for like the roots, leaves, and seeds. And so we will continue on. Going over the key findings, and I'm just going to highlight a couple of things. I know that this like looks pretty intimidating and people probably have no clue. Sorry, can you guys see the laser pointer? Perfect. Really what that means. So I'm going to go through and try and break it down as simply as possible to the best of my abilities. So they found that there was actually a lot of large scale structural variations within the same family of oats. There was a lot of really weird things happening. If you guys remember that first original picture of the circle, there was just all those insane crossovers. And so they wanted to understand more about that. The first thing that I want to highlight is an inversion on 7D. And so I'll point that out to you guys. This is 7D down over here. And what that 7D inversion was in charge of, and I know that this is getting a little wonky, so stay with me. I apologize. I'll bring it all together. An inversion on the 7D has to do with oats flowering earlier. And so I learned from my father-in-law that that is actually a very admirable trait in oats, is that they flower earlier. And the reason behind that is because, let's just say, for whatever random reason in a specific region, there is a period of growth, like, harvesting season that is shorter than, say, closer to the hemisphere. And so that early flowering is super important because it gives farmers, closer to the poles, an ability to grow good oats for people around them and also as a means of income. And that early flowering makes the oats grow faster so that they can do it in, not as favorable circumstances. The next structural variation that I wanted to just touch on was a translocation in the 2A and C chromosomes right here. And so that translocation is linked to higher yields and better adaptation. And I mean, it's pretty self-explanatory. Obviously, as the plants are growing, having more flowering just gives you more oat in the same plant. And so that's a sexy trait, if you will. Moving on lastly to the deletion and duplications that I just wanted to touch on super quickly. So as you can see here, they're comparing three different types of oat. This one has a 6A and 6D chromosome, as does the GS7 variety. You can see the 6A and the 6D. But this middle one had a super weird occurrence where the 6D just vanished and they actually duplicated a 6A, which is super weird to see in natural breeding and genetics. And why that is super interesting is it was likely, this chromosome was likely tied to disease resistance. And this middle one is a North American variety of oat. And there is a specific type of disease here in the States that affects the oats called crown rust. And having two 6As actually made that specific variety of oat resistant to this crown rust. So it's just, natural selection. It's either you sink or swim. And I just thought that was super interesting how, they were able to map that out and find all of that. And then another key finding is the actual pangenome itself. I know I just touched on it briefly for a second, told you guys what it was, but the reason why a pangenome is so important is because it, as I've previously said, gives you the map to understand what traits are linked to, which chromosomes, what physical characteristics, are tied to the gene itself. And it's really interesting how this oat pangenome can actually be used to help farmers and scientists that are working on other crops like rice or barley or wheat get a better leg up on making the best version of the oat. And so I kind of wanted to tie this all together with some other applications of what they were studying. So as I had previously said, this study helps the studies of other polyploids because they're just, due to their nature, they're a little bit trickier to understand and study. Another really interesting thing is once you have the genetic map of a specific species, you can actually know exactly what oats you want to grab and breed to get the best version of an oat, like the most elite, almost like a Superman version of the oat that grows well, flowers well, grows quickly, and, is super efficient with its resources and also can withstand temperatures and all these things. So this study is really in an effort to make a super oat, if you will. And since oats are one of the most complex crops that people have studied and why it was left until just recently is, a huge step because they now have that map and they can use it to guide future research in other areas and other pangenomes. Just for example, wheat is, I don't know if you guys remember, I said oat is like AACCDD, wheat is AABBDD, and so there's some similarities there. They can use this oat study to especially help with wheat, which is kind of interesting. So wrapping things up in conclusion, I just wanted to kind of give you guys an outline of what we just talked about. Oats have, complex, highly rearranged genomes, making them a little more difficult. The pangenome obviously helps breeders select better oat traits, hopefully helping them to create that, I guess, super oat, if you will, and that would allow for people all over the planet to have better access to, high quality protein vitamins and minerals through these oats. And then lastly, as I have said, just these admirable traits that come from this research is 2 thumbs up, and it's something that needs to be continued to be pushed. And with that, I would love to jump into questions. And if anyone has any questions right off the jump, then we can take them. But if not, then I'll just kind of jump into a couple questions. Jeff?
And this may not be within the frame of this study, but I'm interested to know, you talk about better, you use the word better a couple times. And I think I'm understanding that to mean easier to harvest.
Yeah, among some other things, things like providing more nutrients, higher yield, things like disease resistance. So harvest has a big part to do with it, but also on the consumption end, there are admirable traits that they are trying to bring out in a, offspring of these oats, if that makes sense.
And as part of that, kind of a follow-up, as you create these different genomes, essentially, or as you switch this up, the nutrients stay the same, but as far as have you seen anything on like how your body processes these new genomes, or if there's any change in the way that you process those nutrients? Because it's one thing to have those nutrients in the oats, but I wonder if there's changes in how you process these oats.
Yeah.
This is a question that I'm really interested in learning more about that.
Interesting. That's a great question. That's a little above my pay grade,
Well,
of course, but yeah. Is there any like geneticists in the room or anyone that would like to weigh in on that a little bit better?
No, but I do have another question.
Okay, let's hear it.
Sorry, I'm not a geneticist, so I don't have a good
That's
answer.
okay. I look forward to talking more with you later.
Yeah.
Yeah, and I'm even happy to run it by my father-in-law because he's definitely got a question. So let's
So-
get an answer.
My question is, and don't take offense at this, but why did you choose this article?
Well, I don't know if you heard at the beginning.
Maybe you said that, see, I came in a couple minutes after you started, so you
Yeah.
properly explained, and I do apologize.
Not a worry.
That's my bad. So why this particular article?
Ultimately, in complete genuine sincerity, it was in an effort to understand more about what my father-in-law does.
Okay.
I just thought it was interesting, but didn't really understand much about what he does. I had heard that he has published articles in Nature magazine and that his work is super good stuff.
And he's one of the
And-
authors of this paper.
Yeah, yeah, he's one of the scientists behind all of the mapping and sequencing of the actual genetic data, if you will. So,
So then the follow-up question for
Mhm.
that would be, how would you or how would we, and so you don't have to answer this yourself, others can answer this question, but how would we relate this to maybe the health and well-being of the farmers, the health and well-being of the public, who consume the different types of oats depending on where they live? So that's
Mhm.
a question for you, but also for the rest of the group is, okay, what is the connection between this these concepts and this, what they found here,
Mhm.
and those things that we as occupational health folks would use this for?
yeah, and so I actually have my answer to that question, and we can jump forward a little bit and jump to let's see. I think I talked about it here in this question. I wanted to weigh in and get a group idea of if people think this is GMO, like genetically modifying the organism, or something else. I don't know. Do you guys have any idea?
Literally GMO, isn't it?
So I learned that there is a difference between GMO and what these guys do, which is natural breeding. So GMOs are direct DNA modification, like inserting, editing, or deleting genes. Everything that these guys do is all based off of natural selection and things that the oats are doing themselves. So tying into us, occupational health and safety people in general, this study would help to kind of start to chip away at the use of GMOs and allow for people to produce healthier and more sustainable and better for human consumption oats and other crops that just are healthier for the environment and for people in general, if that makes sense. Is that good?
Yeah,
Decent answer to your question?
That's great.
Yeah.
I think my
You
point
actually
was just
answered my
kinda-
question too.
Oh, right.
Love it. Deal.
So, yeah,
Sweet.
was just making sure we understood the OEH.
Yeah.
Here.
Yep.
And
And
that's great.
I was going to tie it in, so I appreciate the
Yeah.
prompt. Thank you
See-
very much.
You're welcome. You just pay me afterwards. It's fine.
Yeah, that's awesome. Yep.
Okay, full disclosure, I don't know that much about GMOs, but since this is kind of tracking all the different like genetic changes, whether it is like deletions or like the swaps, could that guide GMOs? Like, cause you were saying that like, oh, somebody could use like this genome, but if you don't necessarily have the plant, could you
Mhm.
modify an oat to look exactly like if you wanted a European oat?
Yeah.
And you lived in North America, could you modify one of your North American oats to look like a European oat?
Mhm.
Or is that gonna have like other consequences?
Yeah, when talking with one of the scientists, he actually said that sometimes they will do that, whether, politics, world circumstances, financially, they can't afford to get that crop. They will, for scientific reasons, modify an organism to see the outcome of breeding things together. But my understanding, the scientists in this study only ever use it like GMO for scientific purposes. It's never like put out into the farmers, that circle of farmers to actually be grown. So that's a great question. And yes, I think sometimes they will do that.
And there's a whole bunch of laws and policies about this. I mean, if you've traveled internationally, you know that they're gonna ask you whether you brought any
Mhm.
fruit or anything back from the other country. Maybe there's an invasive form of oat, maybe
Yeah.
if you got an oat from another continent and brought it here, it would then take over and replace grass. I mean, who knows?
Yeah.
So,
And tying it in
yeah.
even more to health and safety, a great thing that would be an outcome of creating more robust and just resilient oats is that it would help us to start to do away with pesticides and other harmful chemicals that, as people consume, obviously have, adverse health risks and health effects. And so I thought that this was just super admirable what they're doing to start to chip away at the use of those chemicals.
So this may be related to the last bullet point. I was scanning through to look at how open access, open science this was, and it does feel like a very open science effort. However, it doesn't prevent a U.S. company from using the genetic science to try and patent a new variety. And I don't know a ton, but I do know enough that patented varieties of corn, for example, that are resistant to pesticides cause a great deal of stress and financial harm to farmers who, if they're adjacent to a field that has the genetically modified corn,
Then all of
and it crossbreeds, they legally can be persecuted or prosecuted for keeping seeds of their corn, which was not planted as a genetically modified seed. So
interesting.
There's a lot of promise, and it's really important, especially with climate change, for this kind of science to be done and for farmers to be adapting to climate change. But there's also the policy issue of patented seeds can have a real serious implications for the workers and the farmers, and also for society. In that case of the corn, it facilitates the use of more pesticides of a particular type. The seed was bred to be a partner with the pesticide.
Yeah, I mean, that's a very interesting angle that I actually hadn't thought of. And, there's a lot of things that I guess get pretty tricky as things are going forward. So, yeah, thank you for that insight.
One question I have is kind of on the same point about reducing pesticides and harmful chemicals. We know that biodiversity is very important for a species to kind of per se. So when you're doing these genetic modifications, it's unclear whether you're adding or taking away from the biodiversity that already is kind of within the species. I guess a question for you is, how do you think that may impact oats long term, let's say?
Yeah.
And not only our ability to grow them, but also our ability 50 years from now to have a branch of oats which can grow, really well in, I don't know, Utah versus North Carolina, right? With climate change, I think it's if we breed oats to be grown really well now, we'll just grow a lot of oats until we can't grow anything anymore.
Yeah. And I actually really appreciate you bringing that up, because that was one of my biggest question marks with the study, is just understanding more about that process, which is called domestication. So I'm glad you brought that up, because that's why I put this graph right here. So domestication can definitely cause some issues. And in, forming, and I mean, you can just see it right here, as these are all the ancestral and wild ones. So I don't know if you guys remember, I'll just jump back to the slide really quick. This, like, they already don't have that type C. It's already been just kind of done away with naturally over time, because it wasn't as useful to farmers as others. And so that domestication of oats is tricky for the species as a whole, because you go through and you start losing little and a little bit here, a little bit there of this biodiversity, and you end up with these like elite versions, which are great, but also the biodiversity question is and could be, something that has some serious impacts that might be more negative than actually developing like an elite version of the crop. And so that's a great thing to touch on, and an interesting point to bring up, kind of just the other side of the coin. And yeah, so I don't know the answer if it's a good thing or a bad thing, but it's there. So yeah.
What are the little moons and suns?
Those just represent, these up here. That's just like the cycles of, days as things are growing and progressing. Then we just end up with, yeah. Good question. No worries. Anybody else? I mean, you guys might not ever dive into oats like this again. Take your opportunity as it's here, All right, perfect. Well, I appreciate you guys. Thank you very much.
Back same time, same place next week. Reminder, I think you all probably know by now, but there is a guest lecture right before Journal Club next week at 11 a.m. So if you can, come to that. Dr. Taylor, colleague of Joe's.
Yeah, Dr. Jen
she's
Taylor.
great.
She actually was here a couple years ago, and those who were here then remember that she did quite a memorable presentation then. So I anticipate being similar. So if you're available before, come enjoy that lecture, have some lunch, and then participate in Journal Club.